So, let's talk about REST. Most of the time, when we hear this term, the first thing that comes to mind is HTTP or APIs. It's how we build APIs. And JSON, because that's what we get back from these APIs. And that's a pretty common thing to say, as all we read and hear about are, well, RESTful APIs that return JSON. But REST isn't just about building an API that consists of a few HTTP services that return JSON. That's a web API, but not necessarily a RESTful API. REST is much broader than that. It's an architectural style. Let's have a look at the definition. REST, or representational state transfer, is intended to evoke an image of how a well-designed web application behaves. A network of web pages, which you can look at as a virtual state machine, where the user progresses through an application by selecting links, which are state transitions, resulting in the next page, which represents the next state of the application, being transferred to the user and rendered for their use. Well, that's a lot of text, but we'll clarify this immediately. This definition comes from Roy Fielding. He first coined the term in his PhD dissertation to describe an architectural style of networked systems, which you can find at the link on screen. So Roy is, in essence, the inventor of REST. Let's switch back to the definition. It's quite an interesting definition, because it implies that we first had web applications, and then Mr. Fielding described how a well-designed version should behave. This also implies that REST is not a standard. It is an architectural style. When implementing it, we will use standards, of course. A lot even, as you'll notice throughout the course. Also, in principle, REST is completely protocol agnostic. That means that JSON isn't a part of REST, but theoretically, not even HTTP is a part of REST. And that's really theoretical. To be honest, I haven't seen a single RESTful system that does not use HTTP. HTTP is pretty much the web's golden standard, so that is what is used, and from this moment on we will also assume this. But I just wanted to mention this to drive the point home that this is an architectural style and nothing more than that. It is up to us to fill in the blanks with the protocols and standards we want to use, as long as these protocols and standards can be used to adhere to the constraints that come with this architectural style. We will immediately look into those. Now, as the style is intended to evoke how a well-designed web application behaves, we can use a web application to explain that huge definition we just saw. Imagine that you want to read your favorite newspaper online. You've opened your browser. That browser, that's an HTTP client. You point it to a URI. That URI, that is the unique resource identifier. It identifies where the resource lives. In this case, the index page of the newspaper site. When you navigate to that URI, the browser sends an HTTP request to it. The server then does some magic and it sends an HTTP response message back to the browser. That HTTP response message contains a representation of the page you've navigated to. In our example, that would probably be some HTML and CSS. The browser then interprets that resource representation and shows it to you. In other words, the browser, which is our HTTP client, has changed state. Then let's say that you click a link on the page in your browser to access a specific article on the newspaper site, again identified by a URI. A new HTTP request message is sent to the server, and the server again sends back a representation of the page. The page, that's the resource. The browser interprets it and changes state again. In other words, the client changes state depending on the representation of the resource you're accessing. And that is what representational state transfer, or REST, means. Let's map that to building an API. We'll use an example API with authors and courses, as that is what we will use throughout this course. The HTTP client can be the browser, but more often than that, it's a server-side web app, a console application, an Angular application, a desktop application, anything really that can send HTTP requests and respond to them. It wants to get an author from our API. It thus sends an HTTP request to the URI where that author resides, and our API sends back a representation of that resource as a response. These days, that's typically a JSON representation, but it does not have to be. REST doesn't have a use JSON constraint or anything of the likes. You can easily build a RESTful API that returns XML or some proprietary format, or you can support multiple formats. Anyway, our client gets back the representation and changes state. And then we can continue. Ideally, the client learns from a response where additional resources can be found and then sends a request to the URI of another resource, say the author's courses. The API sends back a representation of that, and the client changes state again. And with that, we now know what REST is. But how do we build such a system? Well, architectural styles are described by a set of constraints. It's these constraints that we'll have to adhere to. Let's have a look at those constraints.